Thank you very much for inviting me to give this presentation today about non-probability surveys. As Aline has already said, this is joint work with some colleagues at GESIS, and it is heavily based on the survey guideline that can be found on our homepage. I'm Barbara. I'm a survey methodologist and survey statistician at GESIS. I'm the head of the team Survey Statistics, and my research interests are mostly concerned with survey non-response. It's to explain survey non-response, to develop strategies to prevent non-response, and after the survey process to mitigate non-response bias by weighting strategies, for example. So my presentation is structured as follows. So I will start by defining and discussing probability surveys as a benchmark that I will then compare to non-probability surveys as a deviation from this benchmark, all using a survey data quality perspective. I will afterwards give you some ideas on why non-probability surveys cannot be used to infer from the survey to some target population, followed by a discussion about when are non-probability surveys fit for purpose. And in the end, I will give some examples on how to collect good quality data if conducting your own probability survey is no option for your research project. So starting with probability surveys, there's a clear definition for probability surveys. In a probability survey, each member of the target population has a known and positive, so non-zero probability of being sampled for the survey. The probabilities don't have to be equal for all sample members, but we need to know them in order to account for them in the analysis. So you can see that on this chart here. So we have some target population we want to speak about using our survey data, and we need some sampling frame for this population. Let's, in the German context, if you want to infer to all Germans, we would have, for example, registers as a sampling frame where all the people who are registered in Germany are presented. And from this frame, we draw a random sample of individuals that we really want to survey. We cannot survey the whole sampling frame, of course. So we draw the sample. We can do this in 1 or 2 stages or more stages. Like, for example, first drawing cities and afterwards drawing individuals from cities, but we know the full process. We know for everyone who is in our sample, in the end, we know the probability of being sampled. And then from this sample, of course, this is the people that we invite to do the survey. Some people respond and some don't. So even if the respondents are the minority of the random sample, we know who we would like to have surveyed. And we have some information on them usually, like we know in which region they live, or maybe if it's registers, we know their age and gender. So examples for sampling frames, as I already mentioned, would be the population registers, like the Einwohnermeldeämter in Germany. But there also could be a list of telephone numbers, so we don't have to have addresses. We can use telephone numbers, and we have lists here using 2 frames, landline and mobile phone numbers, and we can randomly select telephone numbers from these lists. Or in countries where there do not exist registers, like random route approach would be a way to get lists of addresses and then go to these addresses and sample individuals randomly to interview. All these are random sampling frames. How to draw from these sampling frames? As I said, it could be more stages. It could be 1 stage. If you have the communities, you would the registers, you would first draw communities and then individuals. From the telephone lists, usually more, not usually, but sometimes more than 1 person can be reached via the same telephone number. So there has to be some random mechanism again to choose which of these persons to interview. And the same, of course, holds for addresses or housing units. If there live more than 1 person, you need to randomly choose one of them. But you know, for all these steps, you know the probability of being sample. So if 3 people are living there, your probability would be 1/3. So examples from the German context, probability surveys using registers would be like the ALBUS or the German ESS. For the random digital dialing based surveys would be Forza Omnitel. For panel surveys, we don't only have cross-sectional surveys, of course, we have panel surveys as well based on population registers, like some recruitments of the GESIS panel POP or the German Internet panel. Another way of getting a probability panel survey would be to piggyback on surveys that have been conducted cross-sectionally, like at the end of the ALBUS, for example, asking respondents if they would like to participate in the GESIS panel POP. Or the Forza OmniNet panel works in a similar way. People from the random digital dialing based Omnitel panel would be asked to participate in a Forza OmniNet panel. And these panels or these surveys, they can be conducted in any mode. There are telephone surveys or face-to-face surveys or web online only surveys, but they all are based on offline recruited individuals from some sort of probability sampling. And there are, of course, many, many more of these surveys that I didn't mention here. So the sampling is an important aspect when we talk about survey data quality. And you can see here the total survey error framework, which you probably are familiar with, which divides the survey process and quality aspects into two arms. We can see the measurement side and the representation side. And this presentation is concerned with the representation side, as the system is more affected by non-prop or prop sampling. And we can see the same stages here as we saw in the Venn diagram already. We have some target population or inferential population from which we draw a sample randomly, have a sampling frame, draw a sample, and then we have some respondents. And from this respondents, we estimate some survey statistics of interest, like the income distribution. And we would like to infer this distribution to the target population. So we don't want to learn stuff for the survey participants. We want to learn that for the general population. And all these steps can involve errors that we can see here. And starting with coverage error, for example, if you want to study all individuals living in Germany, we can use addresses from registers. So everyone who lives here should be registered in these in the survey frame, but we know that we are missing some people usually. So we're not able to have a frame for the whole population. So we know that like people living in institutions would not be covered in this frame. So this introduces coverage error. Usually we try to account for this error by acknowledging that the survey is only representative for the people living in private homes, for example. The next error source would be sampling error. So as I said, the step from sampling frame to sample, or to drawing the sample. And again, in our context of the individuals and the registers, we usually draw cities, and within these cities, like only a few cities, we then would draw from their inhabitants. And of course, stuff can go wrong. There can be an unlucky draw. We might randomly, by accident, draw richer cities over proportionally, and that would lead to a sampling error. So if we want then look at the income distribution from the survey and infer to the target population, there might be some problems here. The next error source would be non-response error. That always occurs if people systematically do not respond to the survey invitation. So for example, we know that less educated individuals tend to respond to lower degree than higher educated individuals. And if we do not control for that, this also introduces error in our survey statistics. So this framework is really well known, and it describes all the steps separately in a nice way. And for all these errors that are described here. There's a lot of research going on how this error occurs, how it might be prevented, and what can be done to mitigate it in the end. Like for the non-response error, we know that sending reminders helps to increase response. We know that certain groups are underrepresented, and we know that we might be able to compensate for their loss by weighting techniques. The total error framework is defined for for probability surveys, and so all these approaches to mitigate errors do only hold for probability surveys. So coming to non-probability surveys, they are, as I said, deviations from the gold standard of probability surveys, and I just jump in with some examples for non-probability surveys, like all sorts of volunteer samples, like online access panel surveys, where you're asked to register for some open access panel, and people tell you get, I don't know, some credit points or money for every survey that you conduct with them, or student surveys, like universities. Sometimes you need, in order to pass your class, participate in some survey. River sampling is a special form of volunteer samples, online only, where, for example, social media advertisements are sent via Facebook for people registered at Facebook, where they are invited to participate by some survey. And then sometimes snowball sampling are asked to send the request to people they know, or people with some specific characteristics that are of interest for the researchers. And all of these surveys have in common that people volunteer. We don't have a sample where we ask people to participate, but it's the other way around. We ask everyone, and whoever wants to participate is allowed to do that. Getting closer to the online access panel, this is a really common way of conducting non-probability surveys, and there are some great agencies that you probably know. Here, individuals get some advertisement, they can register to participate, and then once in a while or regularly get invitations to surveys that people are conducting. And not always every participant gets this invitation, but also only subsets of individuals, and then they get some bonus for that. It's often conducted as quota sampling. So from this pool of registered participants, researchers can say that they want to have 50% male and women, and so on. And these surveys can be really cheap, but it's really untransparent regarding participation. We don't really know who's in there. Student surveys, even more extreme. I mean, you know who's in there. It's students, and but they're a really selective group of the population, obviously. And these surveys are often combined with experiments, like behavioral experiments. One part of the group gets some treatment and the other doesn't. And this really guarantees internal validity. It's randomly distributed within this group, but it's not clear how this refers to the general population. So this external validity is highly challenged here. Social media ads recruitment, even more selective in a way, because it's only can reach people who are on these platforms where the ad is fielded. Like for Instagram or for Facebook, the system often allows you to target by some characteristics. So say we want to have more females, or by age groups, and then these ads are distributed to Facebook users, but it's really a black box who is approached and who is not. And the algorithm does what it wants. So we can have control on that. And it's a really cheap method to conduct non-probability surveys, and it's often used to survey hard to reach populations that might be on these platforms, but are really hard to sample doing a probability sample. And snowball sampling, as I said, can then be used to really get into this hard-to-reach population. So once you have one respondent from this hard-to-reach group, you can ask them to distribute the link to the survey in their network and study this population or group. There's some other thing called respondent-driven sampling that seems similar to snowball sampling, but should not be confused with it, because this could actually really lead to probability surveys in some situations, but I don't want to get into that in detail. So looking at the survey process again for the non-probability survey, and we have the definition of a probability survey as comparison here. We have some participants in the end. So this is similar to this prop survey, but we don't really know anything about the non-participants. So we don't have a frame, we don't have a set of people that we wanted to have in our survey. So we have some group we call reached population. So these are all the individuals who saw the advertisement for the survey, but we don't know who these people are. So for the access panel, we might get the information who was really invited to this access panel, but on a higher level, we don't know who's part of this access panel. We don't know who saw this invitation, but did choose not to participate. And that's important if you remember the steps of the total survey error. And we don't have a clearly defined target population either. So we call it a universe here. So it's some group, some higher ordered group, but we don't really know who we are talking about. So it's important to state, to see that I didn't use the same terms here. So sometimes people speak of respondents when they talk about non-probability surveys or about a sample, but that's not true in a strict way. As we saw, there's no sampling process, so I would not call it a sample. And as we don't know anything about the counterpart, the non-respondents, it's not valid to talk about respondents. It's participants here. So we should make some distinctions verbally here. So this brings me to the discussion about why non-probability surveys cannot be used to infer from the survey to some target population. As we saw, the selection process is really not clear, and in order to be able to speak for some target population when using the survey, we need to make some really strong assumptions. So the first assumption is ignorability, which means that whatever leads to participation, whatever characteristics determine or affect whether some person participates in the survey, they need to be not related to the stuff that we want to measure or known so that we can correct for. So as an example, if we want to study voting behavior, and we only field some ads on some social networks or on some newspapers, it's likely that political attitudes of readers for some newspapers are different than political attitudes of readers of another newspaper, and these are correlated to voting behavior. So this would be non-ignorable response. In this case, if we know the attitudes and we know some benchmarks for that from the general population, we might be able to do this weighting and compensate for this error. But in this case, we really need to know all characteristics that affect participation. And for like a Facebook survey, that would mean characteristics that affect whether I'm registered at Facebook at all, whether I received this invitation to the survey, and reasons for deciding to participate in a survey. So there's lots of mechanisms that we need to know in order to get rid of the selectivity by weighting and fulfill the ignorability assumptions. And it's really unlikely. So there usually are unobserved confounders, unobserved characteristics that determine participation. The other thing is positivity. This means that every subgroup of the population under study needs to be represented in the survey. It doesn't have to be represented proportionally to the size in the population, but it has to be there. So if we don't have any highly educated women age 30 from Bavaria in our survey, but we do have in our population, we can't do anything to compensate for their loss. I mean, we can't even wait for that or whatever. So if there's no one, we cannot give them more weight. So this is another strong assumption. So every population in a group, and it's highly dimensional, of course. I just gave some 4 sociodemographic characteristics, but of course other characteristics would fit in here as well. Must be here in this survey. So looking at the total survey error framework again, we can see that for non-probability surveys, all these steps that we like to distinguish for probability surveys and have measures for them and ways to compensate for them cannot be distinguished for non-probability surveys. So we don't know why someone is reached, why someone does participate. It's all steps that we cannot distinguish. We just know who's there in the survey. And so we call all these error sources combined selection error for probability surveys. So again, weighting is likely to fail because we do not have all the information usually to make the ignorability assumption fulfill. So yes, so there will always be error left, even if we weight by the demographics that we usually know. And as I said before, for the probability surveys, there's selectivity, of course, by non-response also, but we have so much experience and so much research done, who is missing and why do people want to respond and not. And it's only this step, this non-response step, that we need to really model. So it's easier to find all the characteristics or most of the characteristics that affect selectivity here. And of course, we don't have any design weights, so we don't know the probability and to be reached for, I mean, there is no sampling, but to be reached by the survey, and it is 0 for many individuals. So who's not on Facebook has a 0 propensity of being reached by the Facebook survey. And often we do have information about the participants. We know their age because we ask in the survey age, gender, and education, and usually non-probability surveys then just make these variables match to the general population and claim the social representative now. But it's not enough because, as I said, there's so many characteristics affecting who will participate that just making it right for 3 variables does not seem to do the job. Some of the online access panels, they use quota, as I said before, and basically for the same characteristics. So they make sure that the participants of the survey, they match distributions of age and gender and education of the general population. So 50-50 gender distribution, for example. And then again, they claim it's representative for age, gender, and education, but it's not enough to have the right amount, a proportion of women. The survey is highly selectivity to begin with because of this recruitment process. So it's just the right proportion of people from this highly selective source doesn't make the survey representative. And so positivity is violated here usually because we don't have all the subgroups in this pool, and of course ignorability as well. So quotas do not solve the problem. A higher number of respondents does not guarantee lower bias. This is an argument that is really often made, that these very cheap panels, we can afford lots of respondents or participants, and we have a high sample size, and so everything is not that bad. But of course, we know that sample size is not related to bias. It's related to precision of estimates, but not to their bias. So if you have a selective group, it doesn't help to get more people from this selective group. So it doesn't help the data quality at all. Also, there's no clear definition of the estimation of precision of statistics we get from these surveys. So the variance formulas that we know, they are all developed for probability surveys, for probability sampling, and they cannot be transferred to non-probability surveys, so they're just not correct. So what people usually do for non-probability surveys, they do resampling, like Jackknife or Bootstrap, where this process is repeated. So we resample from the survey participants over and over again and do our estimate, and then get some distribution of these estimates and get some estimate for precision. But it's also grounded on random sampling and cannot easily be transferred to non-random sampling. And if you want to do that, if you want to bootstrap and get a really valid estimate for precision, we need to include all the selection steps in this bootstrap algorithm. So if we do that for probability sample, for example, we would have to feed design weights in there. We need to make sure that it accounts for different probabilities to be selected. And we can do that for non-probability surveys as well when we use estimations of propensity scores derived from other surveys. But again, these propensities must be really, really well estimated, and we need to have all the information in there, why people do participate. And again, this probably will never hold. So ignorability and positivity, again, are challenged here as well. So having said that, is there any use of non-probability surveys at all? So when are they fit for purpose? So they can be used for several purposes, basically whenever statistical inference is not the aim of the study. So for example, testing theoretical concepts, and then fielding the study on a large-scale probability survey. Yeah, so, or if you want to generate hypotheses that you then want to test on a probability survey, qualitative research usually doesn't need or doesn't rely on probability surveys. And of course, for all pre-testing purposes, non-probability surveys are well suited if you want to test your filtering of the questionnaire, to like check whether everything works as you wanted. And of course, hard to reach populations. We usually don't reach enough of these individuals who are hard to sample, identify, find, contact, persuade, and interview. So we don't have them in probability surveys to a large amount to be able to say anything about them. So the only option often to get many respondents or participants would be non-probability surveys like snowball sampling. So once we, maybe starting with a probability survey, we have participants from these groups we want to study, then ask them to give the link to the survey to their friends from the same group. So generalization of results from non-prob surveys is not only non-valid, it also can severely harm general trust in scientific results. And I think we all saw these discussions about extreme findings from surveys that have shocked people and politicians, that were just then proved to be non-reliable because they came from some sort of non-probability surveys. So it's really dangerous to communicate findings from the non-prob surveys to larger audiences, and especially if they are meant to or expected to inform political decisions. It's really, really important to have good quality data that is not biased in any way. And then if people find out that this is not the best source, will not believe in surveys anymore. So what can you do if you want to conduct your own study, conduct your research, test your hypotheses, but you don't have the money, budget, or opportunity to conduct your own probability survey? I mean, like I said, it's a intense process, creating a sample frame and then sampling and then doing these interviews. And there are, of course, well-established academic probability panels that you can use to field your questions, like the GESIS panel pop. This is free of charge, and you can submit your proposals, and then they undergo some scientific peer review process, and then you might be able to field your survey. Or the German Internet Panel, which has some lower barrier of entry, but you need your own funding. The sub-ES sometimes has calls for questionnaire modules, and there are others, like occasionally Frida or CLAS or DECIM or other surveys that allow you to field your own questions, and you can use this well-established infrastructure. You don't have to use open access panels here. There are also well-established non-academic omnibus surveys, like the Forza Omnitel or Forza Omninet that I already talked about. They also have very low barrier of entry. They have short field periods. There's not much processing delays. Of course, you need your own funding, but there are no application deadlines, so you can approach these surveys whenever you like. And there are, of course, other offline recruited surveys that allow to field your own questions. So with that, I want to thank you